Hi, I'm Palmer. Earlier in this training course, we explored how lighting is used in automotive applications. In this training module, we'll be covering the design, operation, and use of incandescent and halogen type lights.
Incandescent and halogen bulbs are thermal radiators that produce light through thermal energy. This means the more strongly these types of bulbs are heated up, the higher their luminous intensity will be. At times referred to as a lamp or light globe, we most likely have a basic understanding of what a bulb is, but there is more to one than meets the eye. Put simply, a bulb produces light by transforming electrical energy, which flows through a filament, into heat energy. This process can be described by a word you have most likely heard many times: incandescence. The filament, which is enclosed within a glass envelope, is a type of resistance wire that is commonly made from tungsten. As current flows through the tungsten filament, it burns and becomes white hot. The changing of electrical energy to heat energy in the resistive wire filament is so intense that the filament begins to glow and emit light. The bulb must have a vacuum or inert gas surrounding the filament to prevent it from reaching a temperature where the filament burns out. The glass envelope that encloses the filament maintains the presence of this vacuum or inert gas. If air is allowed to enter the bulb, the oxygen would cause the filament to oxidize and burn up. During the service life of standard incandescent bulbs, the tungsten filament will be consumed and the glass will turn black from the burnt tungsten particles adhering to the inner of the glass envelope. A disadvantage of these types of bulbs is their inefficiency, converting only about 8 to 10% of electricity used into visible light. The rest is heat energy. Single filament bulbs, as the name suggests, utilize one filament to produce light. These bulbs are generally used in positions such as courtesy lights, dash lights, indicators, reverse lights, number plate lights, and fog lights. There are some bulbs which have the ability to function in more than one way. These types of bulbs generally have a dual filament installed in the glass envelope. By adding another element to the bulb, it is possible to achieve two different light outputs in one unit. This is useful in applications such as stop tail lights and low and high beam headlights. There are several types of incandescent bulbs used in today's vehicles. The differences between these types of bulbs lies in the base design. Bulbs are coded with numbers for replacement purposes, such as H4, H7, and such like. Bulbs with different code numbers might appear physically similar, but can have different voltage and wattage ratings. There are some simple reasons why incandescent bulbs are still used, such as their proven track record, low cost of manufacture and purchase, simplicity of design, decent service life of the bulb, and the ability to make the bulb at different shapes and sizes to suit the application with ease. However, the following factors can have a negative impact on the service life of incandescent bulbs: mechanical loads through impact and vibrations, high temperatures, starting process, voltage spikes, and excessive onboard voltage. As a rule of thumb, if the supply voltage of a light is increased by 5%, the luminous flux increases by 20%, but at the same time, the service life is cut by half. In the case of undervoltage, such as when the alternator is faulty, the opposite is the case. The light now has a significantly higher red share and the luminous efficiency is correspondingly lower. Halogen is a term used to identify a group of chemically related non-metallic elements. These elements include chlorine, fluorine, and iodine. Halogen bulbs are an improvement from the standard incandescent bulb. The major difference with these types of bulbs is they are filled with a halogen gas. These bulbs have a much longer life and are generally brighter and produce more light per unit of power consumed than the standard incandescent bulbs. However, the halogen bulbs become very hot when in use. The elements can reach temperatures of around 3,400 degrees Celsius. They are manufactured from highly heat-resistant materials, and the bulbs must be handled carefully because they are sensitive and can be easily damaged even by finger oil residue left by fingerprints. If the bulb glass is touched, it must be cleaned immediately to prevent the oil creating hot spots and damaging the glass. When a halogen type bulb is in operation, there is a unique cycle that occurs that increases its service life. In the direct vicinity of the hot bulb wall, The evaporated tungsten combines with the filling gas to form a translucent gas, tungsten halide. If the gas approaches the filament again, it breaks down due to the high filament temperature and forms a tungsten layer, in essence, regenerating itself. There are two different types of halogen bulbs available, single filament or dual filament. In dual filament bulbs, the filament for low beam is fitted with a cover cap. This is the task of covering the dazzling share of light and producing the cutoff line that you will notice when driving with low beams activated. There are a range of halogen bulbs that, without increasing current draw, the heat output can significantly increase the lumen output by up to 200%. The trade-off is these bulbs usually have a reduced service life compared to standard halogen types. As it can be seen, there is more to the vehicle lighting system than meets the eye. With the constant evolution of the automotive industry, these systems are improving at the speed of light. Be on the lookout for our other training modules on advanced lighting technology. I'm Palmer, keep training, and thanks for watching.